Hi everyone, welcome back to Dave's Math channel. This is my continuing feature on the Math Lovers book, and as I do every Saturday, I'm featuring a biography of a famous mathematician. These are featured at the end of Volume 2. I have 80 biographies of famous mathematicians throughout history listed chronologically. Um, and I'm up to the 14th of those, and that one is Albrecht Durer, and he was a German Renaissance, kind of a Renaissance man. Lived from 1471 to 1528. Anyway, here's a picture of him. And his main mathematical claim to fame, I think, was his. He made a 4 by 4 magic square with some pretty amazing properties. I'll get to that in a minute. But he did some other stuff too. He studied figures in 2 and 3 dimensions. As a matter of fact, he wrote a work on it called 4 Books on Measurement. And I'm just going to show you his most famous work of art. It was called Melancholia One, and here's a picture of it on the left. And this picture has several references to math and science in it. This was I think it's before the scientific revolution, but it was early in Renaissance when there were a lot of what they called Renaissance men, kind of jacks of all trades who were mostly interested in intellectual activity. It was a big departure from the Middle Ages where people were basically being brainwashed by the church. But you'll see several things on this picture. For one thing, in the sort of middle left, you see this kind of geometric figure. This is a truncated a hexahedron, I believe. He was interested in solids like that. I think that may be an Archimedean solid. I'm not sure. And there's also an hourglass in here somewhere, and I don't know what else. There's a scale. Yeah, but I think the most interesting part of this picture in the top right corner, there's actually a picture of his 4 by 4 magic square, which I believe he was the first person to construct. And I don't know how much you guys know about magic squares, but there's only one up to translations and up to rotations and reflections. There's only one 3 by 3 magic square. That's called the low shoe square. This was discovered in China around 2800 BC. So very ancient, pretty easy to construct though. But the bigger the magic squares get, the harder they are to construct. But also the more possible magic squares they are, and the number possible magic squares of a given order. In other words, the number, the kind of length of the side of each square. As that grows, the number grows pretty exponentially. So for 4 by 4, there's already 880 possible magic squares, and that's not even counting reflections and rotations. But Durer found one particular one, which is probably the most interesting one of all the 880. And the reason it's so interesting is not only, I didn't say the definition of a magic square. I actually have some videos on magic squares you can watch if you're interested in them. But a magic square is just, or a simple magic square anyway. In this case, a 4 by 4 magic square would be a square array of numbers from 1 to 16, such that the sum of every row, column, and main diagonal is the same. In this case, 34. And this is indeed a simple magic square of order 4. But not only that, it has an additional, they show 26 different types of figures in this square that add up to 34 as well. And you can kind of see them. For instance, the corners add up to 34. The 4 numbers in the middle add up to 34. There's a lot of rectangles in this figure that add up to 34. Even tilted squares and rhombuses and you name it. Just about every interesting geometric figure consisting of four little squares in this figure adds up to 34. Pretty amazing. And he discovered, and another thing that's kind of amazing about this, he actually constructed this square in the year 1514. And in the picture, if you look at, there are various ways you can represent the square. Remember, I said that it was not unique up to rotations and reflections because, I mean, you could always rotate or reflect a magic square and it still says magic, but you'll notice that the 15 and the 14 appear on the bottom row, in the middle of the bottom row. So almost like a signature. That's the year he constructed, and those just happen to be the two numbers in those particular positions. Pretty amazing. So I would say that was Durr's greatest mathematical accomplishment. And anyway, that completes my video on Albrecht Durer. Thank you for watching. Long live math, and I'll see you guys next time. Bye.